In order to show that the weaker conditions do not guarantee the stronger conditions, we'll have some examples to demonstrate that one. One example is that consider a binary sequence of independent random variables. Suppose that x of n to be either 1 or 0, but with a varying probability. Suppose that x of n is equal 1 with probability of 1 over n, and with probability of 1 minus 1 over n. So x of n doesn't take any other value. So probability that x of n is equal 1 is equal to 1 over n. And you see that n, as n increases, this x of n, this probability becomes 0. So as probability of x of n equal 1, limit of these when n goes to infinity becomes 0. So therefore, x of n as n increases will become equal 0 with probability of 1. So what we get is that probability that x of n be bigger than any epsilon, assuming that epsilon is positive, is not 0 and is positive, then this is equal to, because x of n cannot take any other value other than 1, it becomes probability of x of n become 1 and is equal to 0. This means that x of n, when n increases, converges to x equals 0, 0 in probability. So you can show. Another example, suppose that we want to calculate if this converges with probability 1, and we'll show that this random sequence diverges in the sense of so here we say that x of n converges to 0 in probability, but x of n converges to 0 with probability 1. So this does not converge, it diverges. So let's prove the second one. So in one sense it converges, in the other sense it diverges. So I leave this one as exercise to you. It's not very hard. Just take the definition of convergence with probability 1 and then prove that the probability that x of n converges with probability 1 is non-zero.